In examples 3 and 4, we want to continue answering those same questions, but we have graphs or functions with a little bit more interesting behavior going on. In part A, we still want to identify where our function is increasing or decreasing. In this case, we're increasing from negative infinity up to this point A. So that's going to be x equals -1. And then union the interval from C to E. So that's going to be from 0 to 1. And then our function will be decreasing over this interval from A to C. So from -1 to 0. And then again from E to positive infinity. So we'll say union 1 to positive infinity. In part B, we're interested in concavity, so where our function is concave up and concave down. If we look between on the interval from B to D, we can see that our function is making this concave up shape. So we would say from -0.6 to 0.6, our function is concave up. And then on the remaining intervals, our function is following this concave down shape. So from negative infinity to -0.6, union 0.6 to infinity. Then looking at the end behavior, in both directions, our function is headed to negative infinity. So the limit as x approaches infinity of h of x will be negative infinity, which will be equal to the limit as x approaches negative infinity of h of x. In example 4, again, we'll start off with intervals of increase and intervals of decrease. Our function in this case is only increasing on this interval from point B to point D. So we'll say it's increasing from -3.3 to -1. And then it's decreasing from negative infinity down to B. So from negative infinity to -3.3. And then at D, continues decreasing again. So we'll say union 0 to infinity. In part B, we'll investigate concavity again. We can see that from A to C, our function is making this bowl shape. From negative infinity to A, we have this upside down bowl shape. And again, from C to positive infinity, we have that upside down bowl shape. So our function will be concave up on -5.7 to -1, and concave down on negative infinity to -5.7, union -1 to infinity. And then finally, we want to investigate the end behaviors of this function k of x. As x is headed to infinity, our function value is just decreasing, so we're headed to negative infinity. But as x approaches negative infinity, we're getting closer and closer and closer to the line y equals 0, meaning we have a horizontal asymptote, and our left end behavior as x approaches negative infinity will be 0.